Now, another area that we spend a lot of time on is photoacoustic tomography, and I thought this might be of importance to us all because this technology is going to be useful for skin, breast cancer, GI cancers, head and neck cancers, and also for sentinel lymph node imaging. And if you're not familiar with it, what you're basically doing, normally with ultrasound, you think of a wave coming in, hitting an interface, and then reflecting back. And you get this interference, constructive and deconstructive interference that leads to a speckle pattern. And then we try to read what's in between all that. Well, the situation with this type of imaging is that a laser beam goes in, hits something like hemoglobin that absorbs it, and then generates a little bit of heat, which then is returned as ultrasound. This is an example. So the inherency of photoacoustic tomography is to see anything that will absorb the laser, and you can switch the laser, and then to reflect back in the near IR. And here you can see the blood in these microcapillaries in the skin. And this is where we've taken some gold particles. These are 5 nanometer gold particles in a larger gold particle, in a larger colloidal particle of 160. Think of it like if you've seen picture-in-picture TV, this is particle in particle nanomedicine. And you can see the enhancement of the sentinel lymph node here. But we did more work to try to improve this signal. The first thing we did was we tried to make them bigger, put more gold in. That didn't work. Those things got so heavy they wouldn't even move. You could wait days. It didn't matter. They just, wherever you inject them, that's where they stayed. But then we made them much, much smaller and looked at the marked enhancement. So these technologies, you can use methylene blue, but these technologies can provide tremendous signal enhancement for sentinel lymph node imaging. And this was a project